So we're going to look at two different kinds of calculators. One second, this isn't working. We can use parentheses in either the TI-30X2S scientific calculator or the TI-8384 graphing calculator. The scientific calculator is nice because it's cheap. You can get it anywhere. You can get it at the Weatherford College bookstore. The graphing calculator is a little bit more expensive, but it has just a completely different set of useful functions that we can do with it. So one of these things, let's say you have the financial calculation here. This is a calculation we're going to be doing when we hit chapter 8 of this course. What this is, that this tells you how much $5,000 will be worth in 6 years at 4% interest compounded monthly. Now, obviously, we don't yet have that formula. We don't know it yet. But what we're going to see is that you can put this in the calculator using parentheses, and you can have it do the entire computation all in one fell swoop. So you can have it happen all in one fell swoop. If you put it in exactly like this. Now I'm going to be using a different calculator at the moment, but basically what it's going to do is it's going to do this 0.04 over 12 first, which is what you want. It's going to do this 6 times 12 independently to get 72. Then it's going to add it to 1. It's going to raise it to that power, then multiply by 5,000. In other words, it's going to do exactly what you want. We put this computation in its own set of parentheses. We put this entire computation in its own set of parentheses. We let this go into its own set of parentheses. We used the caret key on the calculator to raise an exponent, which is exactly all the things that we want. And so let me work this myself. You should be getting 6353.71 if you round to 2 decimals. So that means that if we put $5,000 away into an account that earns 4% interest compounded monthly for 6 years, we'll end up with $6,353.71 in the account. So this is an example of a time value of money type calculation. But the important thing to take away is that we're going to use parentheses in a clever manner. We're going to use parentheses cleverly, and we can do this calculation all in one swoop. Now, the calculations do step up a little bit in difficulty as we get into some of our what we call annuity formulas. So let's say we do something like this. This one's going to be a little bit tougher to put into the calculator in one fell swoop. What this does is this tells you how much money you'll have in an account if you put away $250 per month for 30 years and you earn 8% interest compounded monthly. That's what this formulation can tell you. Now, putting it in the calculator is going to be a little bit different than the last one. It's going to require an even greater amount of parentheses. So don't put anything in until I fully have it written out. And this is kind of a pain. It requires a lot of parentheses to get this right. But if you use that exact number of parentheses, if you put that in your calculator exactly how you see it here, it should work. Let me double check that my parentheses matching is good. Should work. And it should feed you the answer you need all in one fell swoop. Let me try it out in my calculator. You should be getting 372,589.86. Is that what everyone's getting? You put in, the exact number of parentheses, 250, open 3 parentheses, 1 plus, open parentheses, 0.08 divided by 12, close 2 parentheses, caret, so on. You finish out the rest of this. You should get 372,589.86. These are real calculations we're going to be doing in the 1332 portion of the class. Now, when we get to that point in the class, we will revisit this idea and the most efficient way to put it into your calculator. And there's a number of different things we can do. But basically, if that's the only way. Yeah, that's the only way to do it in our terms. Well, yeah, you can use brackets if you want. Brackets are just another set of parentheses that are easier to match together. But you can use parentheses ad nauseum. The problem is it doesn't always tell you which is being matched with what. You have to be very careful. This is where you have to use a little bit of reasoning. If this represents the amount of money that's going to be in an account. If I put away $250 a month for 30 years with 8% interest, it shouldn't give you a negative number. It shouldn't give you a number less than 1, like 0.084. That doesn't make any sense. You're going to have thousands, if not hundreds of thousands, potentially even millions of dollars in that account, which is what ended up happening here. We had $372,589.86. So one of the lessons behind this is that you save up for retirement over time. You put away a reasonable amount each month. You also have that retirement money invested in the market. The only way you're going to get 8% interest per year compounded monthly is if you're investing in the market. You're putting it out there so that it can go earn more money. And so that's basically what's going on here. And building all that, you can use, if you work for a company that does do retirement matching, they'll double. They'll put the same amount in your account for you as you're putting in out of their own funds. So for instance, if I put $250 a month away and they match at the full amount that I'm putting in, that means I'll put $250 a month into my account. My company will also put $250 a month into my account out of their own pockets, but it's still going to end up being my money. So you're essentially doubling the amount you're putting away. Then if you're working through your company likely has a relationship with a financial advisor firm or just a straight up life insurance firm or an investment firm that literally will handle your company's retirement accounts. And in doing so, By handling those accounts, they'll invest the money for you. They will take a fee, but they can usually get you a pretty good rate of return, a consistent rate of return. They're not gonna put it all into stock. They're going to diversify your portfolio and put it in a lot of different things, some of which are risky, some of which are less risky based on how risky you tell them you want your portfolio to be. So it's an interesting system, but it's a great way to do this. If you're curious, so we ended up with $370-something thousand. If I put $250 a month away for 30 years and didn't invest it, meaning you put it under your mattress, that's the old saying, meaning that you're just leaving it in a stagnant bank account that's not earning any interest, it's just sitting there, how much would I have? Well, think about it. You got $250 a month. You're doing it 12 times a year, 12 months a year for 30 years. So if I do 250 times 12 times 30, you're going to end up with $90,000, which sounds like a lot, but are you going to retire on $90,000? If you retire in 40 years, with inflation, is $90,000 going to last you very long after you retire? You'd love to live 30, 20, 30, 40 years after you retire. You'd love to keep living on and on. 90 grand is not going to last you a year probably in 40 years from now. 90 grand, which sounds like good money today, is not going to be worth nearly that much by the time you retire. So 90 grand is not enough. Now 372 is still maybe not enough to retire on. So you might have to have other vehicles for retirement than just this account. But the point is 372, that's over 4 times more just because I invested it. In this case, it was the same 250 leaving my pocket every month and going into an account as this over here. I had to do the same amount of sacrificing. But just because I invested it, I end up with over 4 times the amount of money had I not. And you can figure out that the interest earned on the account, that is the difference between what the investment account earned you, which is this much, and what you would have earned had you not invested it at all. And it looks like that's going to be 282. You earned almost $300,000 just by investing the money, more than you would have if you put on your brain. So should you save, when you're saving your money, especially for the long term, should you invest your money? Very likely, yes. If you're doing a short-term savings, if you want to buy a house in like 2 years and you're saving up for the down payment, maybe you don't need to invest it. Maybe you put it in something called a high interest savings account, which is insured by the Federal Deposit Insurance Corporation, which means that if the bank suddenly goes under, your money is insured, you get your money back no matter what. And you can still get a little bit of interest in the meantime, but it's a completely safe way to save for a short term. But if you're saving for the long term, you pretty much have to invest that money. You're forced to, or else your money is going to lose buying power. The amount you're saving isn't even going to keep up with inflation. So you're almost better off just spending that money now anyways on things that will last you for the long run. So those are some good things to know. So we'll be revisiting this idea, but what I wanted to drill into your brains was this idea of parentheses matching. We're going to be using it a good deal to work some of these problems. Our next concept we're going to talk about, permutations, combinations, and factorials. So let's use this top area wisely. A factorial which uses an exclamation mark in mathematics. That is our symbol, meaning we are doing a factorial. A factorial tells us how many different ways there are of rearranging a number of objects. So for instance, if you had 7 books on the bookshelf, there are, here we would use the factorial, 7 factorial, which is actually 7 times 6 times, 7 times 6 times 5 times 4 times 3 times 2 times 1. Whatever that comes out to is the number of ways I can rearrange 7 books on the bookshelf. Now, I believe this calculation is 5,040. So there are 5,040 different ways you can rearrange 7 books on a bookshelf. Now imagine you had 13 books on a bookshelf. If you had to do 13 factorial, and again, we're not formally really defining why this computation makes sense. We'll do that when we get into Math 1332. But 13 factorial is itself a really big number. You literally got to bust out your calculator and do 13 times 12 times 11 times 10 times 9 times 8. That's going to get old really quickly, isn't it? Absolutely it is. So there's actually a much faster way of taking care of the factorial. There's a much faster way of dealing with it. Both of these calculators have a factorial operator built into them. So let's look at if you have the TI-30 X2S scientific calculator. What are you going to do? Let's say you want to calculate 7 factorial like we did above. Find the PRB button on the calculator. It may be written above another button. So let me show you what I mean. Let me show you what I mean. Oh, nope, it looks like there's just one straight up on there. Very good. So here's a nice picture of the TI-30 X2S calculator. Here's your PRB button. So you're going to use that button, but don't press it just yet. First, put a 7 into the calculator on a clear, fresh, brand new line. Put your 7, go click your PRB button, and then you should be able to find the factorial. It's one of them. Scroll down till you're highlighted over the factorial, hit enter, and it's going to bring it down into the calculator screen with you. So you're literally going to see 7 factorial in your calculator. So find the PRB button. So first type in 7, then hit the PRB button, scroll down to the exclamation mark and hit enter. Hit enter again and it'll calculate it. It's good to know. If you're on the TI-83 or 84 graphing calculator, first type in 7 on a clean, fresh line. Then hit the math button. Scroll to the right until you're at the PRB submenu. then scroll down to the exclamation mark. Hit enter, and then hit enter again, and it should calculate it. So if you have the calculator handy and you're doing it, you should be able to do it. Have you all seen it? Is it working? Is it doing what you're doing if you have your calculator? So yeah, you can do the factorial that way. You can do the factorial that way. This is also a good introduction to these concepts because we are going to revisit them and learn about them and be tested over them later on in the semester. So that's how we can do a factorial operator using both types of calculators. Permutations and combinations. This is a new concept. Count up the number of ways of selecting a smaller group of size R from a larger group of size N. There is a distinction between them, though. A permutation, whenever it calculates the number of subgroups of size R you can make from a group of 7, say, or from a larger group of N, it does so, and then it gives you all the ways that those objects can be reordered. The combination simply gives you the number of groups that can happen. Again, we're not necessarily learning about this right now. We're just learning how we can find these functions in our calculator. In your calculator, the NPR is associated with the permutation. The NCR is associated with the combination. If you have the TI-30X2S scientific calculator, let's say you want to calculate AP3. You're going to hit 8 on a fresh, clean line, then hit the PRB button, scroll down to the NPR, and hit enter. Then hit enter again, or no, hit enter. Then type in a 3 and hit enter again. And this will do that calculation for you, 8P3. On the TI-8384, it's going to be similar to the last one. But with a few key differences. You're gonna hit the math, after you type an 8 in, you're gonna hit the math button, scroll to the right for the probability submenu, go down and select NPR, hit enter, type in a 3 and hit enter. And that's how you're going to do it on the graphing calculator. So you should find the math button. The math button should be right here near the top left under the alpha button. You should see math. You just hit it straight up. You hit it straight up right here under the alpha button, but after you've typed in your 8, you type in your 8 first. And then you should be able to then get what you want out of that. What are y'all getting? for 8p3. Let's see. 136, 336. Yep. Very good. You should get 336 for that. And what that tells you from a large group of 8 objects, how many ways can you pull any 3 of them out? And then once you have the 3, how many different ways can you rearrange them on top of that? That's what a permutation does. Again, we'll visit this again. Let's say you want to do a combination. Combination is slightly different from a permutation. Let's say you want to do 9C4. It's going to be almost identical. This time, you're going to type in 9 first on your calculator. You're going to go find the NCR thing in your submenu, in your probability submenu. But it's going to be almost identical. Using NCR.
So what do those variables stand for, like NCR?
So the N, so basically, imagine you have a deck of 52 cards. How many of you, do y'all play poker? Anyone play poker? What the NCR can do is it can tell you how many 5-card hands are possible in poker. Now that's important because that's going to be how you calculate the probabilities of getting certain kind of hands in poker. Now it just so happens there are almost 2.6 million different hands that you can have in poker if you're playing standard 5-card poker. Now if you're playing Texas Hold'em, it's a little different, and everyone plays Hold'em now, but whatever. So basically, imagine you shuffle the deck completely, that's 52 cards, and you draw the top 5 cards. There's almost 2.6 million different 5-card hands you can get there if the deck is well shuffled. That's a lot, that's a ton. 4 of those possible hands are royal flushes. There's only 4 royal flushes out of almost 2.6 million possible hands. So, do you think you're going to get a royal flush? Have you all ever played and seen someone get a royal flush? I've seen someone get a straight flush to the queen. That's the best I've ever seen. That's not quite a royal flush. So it's possible, but it's unlikely. The way we can calculate the probabilities is using combinations. So if you wanted to figure out the number of 5-card poker hands that were possible, you would do 52C5. Because what the combination does is it tells you all the different ways you can pull a smaller group of R objects from a larger pool of N objects. In this case, the number of 5-card hands, it's the number of ways you can pull a group of 5 objects from a larger pool of 52 objects. And so that's what a combination and a permutation calculates for us. There's a difference between the two, which we will get into when we get to Math 1332. Good question. What do y'all get for NC4? 126. So in the case of 9 objects total, you want to know how many ways can I make a group of 4 from that? A unique group of 4. There's 126 different groups of 4 that can be pulled from that. How many 5-card hands are possible in poker? Let's say it's simple 5-card. What is it? Stud, where you have to stand with the 5 cards you were drawn? I think it's stud, or is it draw? Because some of them, when you're dealt with standard 5 cards, instead of playing Texas Hold'em, and the river counts as your hand, you just draw 5 cards, and then you can actually substitute out and get cards back that you want. I think that's draw. But anyways, let's say you're playing simple 5-card poker. How many 5-card hands are possible? That's going to be 52C5. And we can use our calculators to do that calculation. What are you getting? It's a big number. $52C5. I think it's Is that about right? So do 52, bring down the NCR thing, then do 5 and hit enter. I think it's 2,598,880. That's how many 5-card hands are possible in poker. When you want to calculate probabilities in poker, then you would use that as the denominator of your probability calculation, as you will see later on. Why would you care about probabilities in poker? Because the reason a royal flush beats a straight flush is that you're less likely to get a royal flush. It's more rare, so it has more value in poker. A simple, 2-pair or whatever is you're less likely, you're more likely to not get anything special, or you're about as likely to get nothing special in your hand as you are to get something special. So if you do have a 2-pair, yeah, you can play that well. You can do well. You can get people to fold who have a better hand. You can beat someone who's bluffing and has nothing. Yeah, there's nothing wrong with it, but it's the most common hand that actually has any value. It's the one that is the least valuable among the valuable hands. But obviously the least valuable hand in poker is to have nothing. You have jack. So these combinations, permutations are absolutely problems that come up when we're talking about counting and when we're talking about probability specifically.